Hello, everyone, and welcome to another episode of OpenObservability Talks. I'm your host, Totan Horvitz, and here at OpenObservability Talks, we talk about anything DevOps, observability, and open source. So, as I always say, may the open source be with you. And actually, we're now concluding the 6th season of OpenObservability Talks. Really exciting. 6 years. I can't even believe it myself that the time has passed. We're now so essentially it's an opportunity to thank you all for following us, and by the way, don't forget to rate us wherever you get your podcast, and we'd love to hear your feedback, so feel free to reach out, Twitter, X, LinkedIn, Blue Sky, Mastodon, whether to the show or directly to me. Love to hear more from you. And for the conclusion of the 6th episode, I chose a topic that I personally have high hopes for. I'm a big fan of OpenTelemetry, OTel. I even came with a shirt for the occasion. But admittedly, many users find it difficult to get started. We've made significant improvements in documentation, getting started guide, but there's still a high entry bar. So can we learn from each other and get some community knowledge formalized, at least for the common use cases? The new Blueprints initiative comes to address exactly that. At OTel Unplugged Europe earlier this year in Brussels, I had a chance to take part in an unconference session about the blueprints, and then followed up with Dan Gomez, the creator of this initiative, and I even discussed it here on the episode after the OTel Unplugged event. So now I'm really happy to give the stage here at OpenObservability Talks to unveil the first blueprints. And I have Dan Gomez with me to share all about that. So, hey, Dan.
Hello. How's it going?
Good. Great to have you there on the show. And may the open source be with you as well.
May the open source be. And I brought my favorite Star Wars thing that I own, which is a Lego piece of Mando. I'm going to put it back. But yeah, very happy to be here. Thanks for having me.
Yeah. And I also see there on the background the Practical OpenTelemetry. That's the book that you authored about OTel. So definitely yet another testament of your credibility and your experience with OTel. So really glad to have you here on the show. We've been knowing each other for a lot of time. You also led me in my journey when I started the SIG there on the SemConv, Semantic Conventions for CI/CD, and you escorted that on behalf of the technical committee and help us make it happen. I would just say, you're actually, by the way, also a maintainer at OTel's SIG end user. That's where end users come to share their experience. So you probably hear that often from users, what I just described, the pain. So what were maybe the recurrent pain points that end users bring up that later led to the blueprints?
Yeah, I think one of perhaps the main reason to start this initiative is, and it's something that I started to think about when I was an end user myself. Now I work for New Relic, and basically I do speak to a lot of end users, but I was an end user myself not too long ago, right? And I was thinking about if you want to adopt OpenTelemetry effectively, you need to think about the cross-cutting aspects of it, right? One of the things that I keep seeing from end users is that they think about OTel or adopting OTel. Some of them just think about the collector. And I was like, okay, I'll deploy the collector, and that's me done. Some of them will just basically think about it as a replacement for maybe a legacy vendor agent that you drop in a box and it instruments things. But I think what's missing here is that OpenTelemetry is so cross-cutting that you need a strategy of how you're going to roll it out at an organization wide, as in how do all these things play together? How do all these components actually link to each other in a way that allows you to have that that high quality observability data? I think that's what I think was missing, and something that we've seen from end users, that they needed that end-to-end, story, right, of how to do it.
Yeah. So you also used to be a member of OTel's governing committee. So tell us, maybe let me ask it bluntly, why is OTel so complex?
Yeah. So, and this is something that, by the way, as well, I forgot to mention that during OTel has graduated, so we're all celebrating.
Yeah,
This
we
is
celebrated here on the show, by the way, on the last episode, the previous episode, big celebration about the OTA and also the alpha, public alpha for the profile. So yeah, celebrating all of that, and kudos again to all the maintainers, contributors, committee members, and everyone else involved.
Yeah, it is a huge milestone. But we during the process of graduation, and it took time, right? Some of the part of that process is interviews with end users, and that was something that was raised to not just to governance committee, but also to maintainers. Is like, and I think the word at the time, the word blueprints was already sort of like given as feedback, as in like, we want blueprints, right? And then the reason is that OTel is complex for good reasons and sometimes for bad reasons, right? There is that sort of aspect of OTel being cross-cutting, being across many different environments and components. Like there is like that. I forgot the author, but the paper was, there's no silver bullet. How there is like in software there is accidental complexity and there is essential complexity. And OTel has a part of it, which is the essential complexity of adopting as technology across your whole stack. And that goes from how you configure your SDKs to all the settings I use, how you do it. Is it like, you're going to do it like programmatically? Are you using environment variables? Are you using declarative config? Do you need a collector as a sidecar or not? Or do you have a gateway of a collector? What about semantic conventions? What about instrumentation quality? All these things that go with OpenTelemetry. I think that's the complexity is in its breadth.
Yeah.
And then there is the accidental part, which is, I guess, the complexity of like, if you don't have a strategy to simplify this ultimately for your users internally in your company. If you're in charge of, say, your OTel adoption strategy, then you can find yourself in a bit of a complicated mess if you allow everyone to do it their own way, right? If you have like a large number of teams and then everyone does it in their own way, then you put yourself in a corner of like complexity that I think can be avoided.
Yeah, I think I see that very frequently. Obviously, you mentioned that you're an observability architect also, so you see probably lots of deployments in production. We should have mentioned that also on the entry. But essentially, what I see as well is that many times there is no, you're talking about the ideal case where you have like the OpenTelemetry adoption strategy in the organization and someone does that like top down and all of that. In many organizations, the dynamics is very different and individual teams make the selection of OTel for their individual needs, sometimes as a replacement for an existing vendor or a vendor's agent or whatnot, and in some cases for other needs, or suddenly moving from just logging to logging plus additional signals, but then again, because it springs up like bottoms up from the individual teams, each team puts up their own practice, if you will, for how to do that. Sometimes even they don't even try to formalize it as a practice or try to think about it end to end. And there's also the I guess the organizational perspective, who owns it. So intuitively you'd say, okay, platform engineering should be probably the entity that has the overarching responsibility and the breadth of vision across the organization, across the different application teams on how to implement that, and should give some sort of golden path, not just by the way OTel, in general in observability. But in many cases, you actually see that there are individual teams, DevOps, apps that take this approach. And where's the delimitation? As you mentioned, there's the piece about instrumentation that is closer to the app code, and there's the other piece about collection. Maybe different teams own these different pieces. So we call it OTel together, but different pieces of OTel fall under different parts of the organization. And where is the handoff and where is the ownership? Not just both deployment, instrumentation, semantic conventions, the monitoring. And so there's many questions that if you don't look at it holistically, there you
Yeah.
start seeing like hiccups within the organization, especially of course large organization, that you have lots of teams, lots of business units, lots of lines of business, each one doing its own thing, right?
Yeah, I think that's ideally, and I think we're seeing this more and more with, I guess this is not just OpenTelemetry, right? You see that with AI now, where like platform engineering is coming at a stage where like it sort of like necessitates that, like the adoption of AI tooling necessitates a strategy for platform engineering. The same with OTel. I think, when you're thinking about something that gets applied across like teams and code bases and environments and so on, you do need a little bit of you need to reduce complexity for the rest of your organization. So in blueprints, in OTel blueprints, we're not trying to dictate how you should organize your, how you should do your company structure, right? If you should have a platform engineering team or not. We do aim some of the advice of platform engineering teams, but you can still take the advice that we give in blueprints and OTel blueprints as like something that you can take in pieces, right? And if you're like perhaps and then link between some of these different pieces. So if you're perhaps an infrastructure team, and then you just think about deploying monitoring hosts, monitoring infrastructure, you might drop the collector in there, and then you might call it a day. But then the blueprint that we have right now is already published. We'll talk about that later. Basically, will start to give you something to think about in terms of like, well, if you deploy a layer of collectors over here and you have a centralized pipeline, then you can get these benefits. So even though like one single team can take the advice, it might give them, some say ammunition to go to another team and say, well, why don't you provide this as like, if you're the central team in charge of data pipelines, this is what OTel recommends, and this is the benefits of doing that. So maybe, you can do that. You start basically to have those conversations internally in your organization to have that common strategy.
Yeah, actually, it's funny. A lot of times when I came to talk to organizations, I was the one bringing to the table different teams that before did not even talk to each other. I've not talked to each other about this, and like bringing them just because of asking, so who handles this and who handles that, and bring people. And so I'm, as an external guy, brought them to talk to each other, and suddenly realizing but having the blueprints as like an anchor to create even the language of conversation within the organization across the different teams, and starting mapping out the responsibilities, because you have this something to follow on. I think it's very useful. And so you started touching on that. What, before going into the specific blueprints, but what should people expect from blueprints in general? And I know that there's also the initiative combines both blueprints and reference implementation. So maybe adding a second questions about the difference between that, to know what to expect from what.
Yeah, I'll start with that actually. There is, if you go to the OTel, to the OpenTelemetry.io, to the website, the official website, you'll see that we now have blueprints and reference implementations as a section, right? And then the first question is like, and we do explain there what the difference between blueprints and reference implementations are. The way that we like to think about it is that reference implementations are something that in fact, we have already three. I think we have Adobe, Mastodon, and Skyscanner that have basically published the reference implementations for OTel. And those reference implementations are just a point in time, basically. This is the way that Adobe, Mastodon, Skyscanner approached OpenTelemetry adoption at a specific moment in time. So we don't intend those to, we don't intend for any of these companies to come back and maintain that according to their reference implementation, right? If they want to do it, they're welcome to do so and come and update it. But it's not a maintainable resource. It's just a snapshot in time. In fact, they were published as blog posts originally. And this is something that the developer experience, SIG, and OpenTelemetry has been doing so far. I think, this is something that they have been doing for a few months, speaking to those end users, putting together the stories, putting together the learnings. And then in the future, we now have a process basically for those reference implementations we just want to make it easier for end users to give us the reference implementation in a structured way. So that's what a reference implementation is. This company adopted OTel and these components, and this is how they did it, and this is their benefits and what they learned from it. So that's part of it, and we're ready. As I said, we already have some. And then blueprints. What we're trying to do with blueprints is that operates at a higher level in a way. So we're trying to look at some of the common challenges of adopting OpenTelemetry in specific environments, specific scenarios or conditions. For example, you could say, what are the main challenges that you're wanting to solve by adopting OpenTelemetry in a infrastructure-led, so like a non-Kubernetes environment where you might have some Docker containers over here and then some, bare metal over here, and you're interested in like monitoring processes and that sort of thing. That's one, say, archetype that we're trying to find the common challenges, and we're trying to put together a sort of common design patterns to solve those challenges, and then a set of implementation steps. And then, as we will cover that in the future, later, but like another could be, well, this is how you deploy a managed telemetry platform, as in centrally managed, where you have a team that is in charge of facilitating adoption of, the configuration of the SDK and a centralized set of pipelines and so on. Another one could be Kubernetes Observability. That's another one that's currently in progress, where like we're looking at challenges of like monitoring a Kubernetes cluster and the workloads that are in that cluster in terms of the resource utilization, and also some of common Kubernetes components, like you might have cert manager or core DNS and things like that. Like everyone wants to know how to. That is like almost like default in Kubernetes, right? So those are the main ones that. But in terms of the structure of each of them, and this is what how is a blueprint different than a reference implementation? The structure of each of them is heavily influenced by a framework that was put together that was popularized by Richard Rumelt in Good Strategy, Bad Strategy, which is a book that I would always recommend to anyone thinking about strategy. And we can go into more detail later, but in general, what it says is that basically you should structure your thinking about in three main blocks. One is the challenges that you're trying to solve, the main guidelines to solve those challenges, and then the actions to implement those guidelines. So it's a well-structured framework that then allows us to put these blueprints in a way that is easy to consume, and it solves actual problems for end users, right?
Yeah. So essentially,
that was very long.
No, it's I think it's essentially the difference between conceptual guidance and real production stories. So the conceptual guidance in blueprints and the production stories that show for a specific company with their specific needs, pains, and the constraints and how they solved it. So I think this is the way that I at least try and direct people when they ask where should they go, and obviously it's not one or the other. They can read through the reference implementations and look at the blueprints and like take from each one the pieces that are relevant for them. And by the way, I should say that the credit's also for you on the Skyscanner one. You're one of the ones designing the adoption of OTel there, so actually, your signature is there, right?
That made me even happier because it happened after I left the company, right? But all the, I guess that was part of, it was like my baby in a way. So, and it's good that, it was someone else that I picked up that and, started sharing that. It's great to see that as well.
Amazing.
But yeah, so I think you mentioned that there, which is a relation between both of them, right? We do want the blueprints to be based in or backed by reference architectures. So we're not just, picking this advice out of a hat, right? It's just we have seen this work in production. We have seen this work at scale, and the advice that we're given in these blueprints is not theoretical. It's practical as well.
I'm actually wondering also, again, as an architect myself, there's always in systems in general and specifically in OTel the most interesting, one of the most interesting tensions, I guess, is the flexibility versus opinionation, right? OTel, as you mentioned before, is intentionally designed to support many architectures, many vendors, many deployment models. So I guess, how do you create the recommended blueprints without turning them into rigid structures? I'm just wondering how you balance these.
Yeah, so I think that's one of the reasons why we chose that framework of good strategy, bad strategy, and the reason for it is that there are many ways of doing OTel, or many ways to deploy every single component of OpenTelemetry. And the way that we're trying to scope the area, or the scope of the problem, is by listing the common problems to solve. And this is one of the things that the framework is aimed at, is that any guidance or any action to implement that guidance needs to always link back to the problem you want to solve. And in a particular environment, there tends to be a preferred way of doing that. Now, it's not always possible to to do something in the most optimal way. So I'll give you an example. We know that there's a challenge in when people when people start to think about adopting OpenTelemetry at the application level, which is configuring OpenTelemetry across different languages, different teams, different and it's all deployed. Let's say that it's all deployed in Kubernetes for the sake of it, but you deploy it that way. I guess, one of the easiest way of doing that is using the OpenTelemetry operator for Kubernetes. Now, but it may not always be possible to deploy an operator for whatever reason, right? So then we give different options in the blueprint to say, well, these are the main options. We recommend this one if you can, but if for whatever reason you can't do that, well, this one may require more work, which is, I don't know, like creating your own base Docker images, for example, that will have your standards baked in. However, if you can do the operator, it's just a lot easier to do it. Or you should use declarative config, as in like YAML to configure your SDK, but it's not available in every language, right? So it depends on what language you're working with. You may be able to use that or not. So we're trying to give some options in order of preference, where we think that there are many, I guess, equally good ways of doing that. And we're also trying to make sure that whatever we recommend is stable in a way, as in like, this is one of the aspects that we, there's no point in putting together a blueprint for adoption if things are changing next month, right? So I guess, we're trying to base it on like things that tend to be either stable or either not stable. We may recommend it, but say, well, use caution here because this is not completely stable yet, right?
Yeah, for sure. And let's go straight. Really, the exciting thing, the first blueprint just came out this month, and it was really exciting to see that. And the first blueprint essentially is, you hinted to that earlier, about infrastructure, like looking at non-Kubernetes environments, actually. So although we are both all of us in the CNCF, Cloud Native Computing Foundation, sorry, like thinking Kubernetes native, but actually a lot of the users out there still on traditional VMs, even maybe bare metal directly, on-premise environment with all sorts of setups that they need to manage themselves. And the question arises, because OTel is part of the CNCF and Kubernetes is like the first thing that comes to mind, what happens with these folks? Are they do they have a good way of operating? So it was very interesting to see the choice, and this is the first one that has come up. Take the stage. Tell us a bit more about this.
Yeah. So the reason why the first one was that there are three that we were focusing on to as part of the initial set of blueprints, and I mentioned the three earlier. But the reason why I was particularly excited about this non-Kubernetes one is because the reality is that if you're on Kubernetes in OTel, things are a lot easier. As in, like, there's no question about it. You have loads more tooling available to you, either as like Helm charts or operators, or like things to control the config sprawl that you might end up with in OTel, than in a non-Kubernetes environment, right? So basically what that blueprint is trying to cover is some of these challenges that normally arise from, some of them arise from not being in a Kubernetes environment, not having an orchestration layer, like not having a standard way to deploy agents, for example, or to deploy collectors right across your estate, or having completely separate or fragmented instrumentation approaches. Those are the challenges that we're trying to solve. And also basically having these siloed pipelines. So basically, as I mentioned earlier, you might have the challenges that come with instrumenting or deploying a set of collectors across your infrastructure in a non-Kubernetes way, and then not having a central pipeline for all that data that comes with it. Challenges of governance, of if you want to enforce a certain standard or ensure that you have the visibility over what data is produced and what is produced. So those are the challenges that we're trying to solve with that blueprint. And some of our recommendations are around, for example, centrally managing that agent lifecycle and using OPAMP. And I think you mentioned earlier that you had a guest in the show.
We had Andy Keller here on the show. He's, I guess, one of the creators of OPAMP and the core maintainer. So he was here on the show just a couple of episodes ago. So if you're looking for a deep dive on OPAMP and what's new and what's the latest on OPAMP, do check out the episode. I'll share the link on the show notes.
Yeah, so that's a good example, actually, OPAMP, of a case where the specification of OPAMP is currently in beta, right? It's not, if I guess, one would say is it stable? Is it not? People are using it in production and we know that. However, we're mentioning that, it's a standard that's evolving, and we mentioned that in the blueprint, but we also give an idea of how one could work with OPAMP to help manage that configuration sprawl, the way that you manage that agent lifecycle or that collector lifecycle. And then I guess, we're not trying to reinvent the wheel in blueprints. We're trying to link people to relevant guidance. So again, we're not trying to document how OPAMP works, right? That's not what a blueprint is about. It's about how you deploy it and then link it back to to the way that you apply, to the way that you should think about your configuration strategy, right? Where you have normally one centralized bit of config from a centralized team, perhaps, but then you allow other teams to extend that config for the particular use cases, and then how you put all your strategy together.
Yeah, and I think this, just for the audience to understand, that I think the complexity here that you're tackling with the blueprint is really the challenge of the consistent observability across this heterogeneous infrastructure. So imagine these systems having some legacy processes, containerized workloads, mixed infrastructure, VMs, bare metals, containers, whatnot. Yeah. And that's the thing. When you don't have Kubernetes, you don't have this centralized orchestrator that abstracts all of that and gives you a unified set of APIs to fetch, the statuses and to configure and so on. This is the complexity. So this is why I loved seeing this as the first blueprint that comes out, because really these are the places where architects flourish. You really get the non-trivial things that you need to plug, that not all of them are the cutting edge, and all of them are, you said, not even YAML might not be supported, or things that the cloud native folks take for granted. And you still need to address them, and unless you just declare, no, OTel is not relevant for that. And I definitely don't agree with that. So I think this blueprint brings OTel to these environments that people less natively maybe think about, or maybe some of them even, and I heard that in discussions with users and customers and whatnot, some of them just disqualify that because no, but we're not Kubernetes. So we know that OTel is great, but we're still stuck with VMs and stuff like that. So we didn't even bother looking at that. So they to begin with, they didn't even go down this path because of that. So having this blueprint I think, and having it as one of the first ones, I think is really going to be helpful in showing others that are in I don't know if to call it legacy, but other types of environments that are not Kubernetes, that OTel is just as beneficial and not that much of a heavy lifting to make it run effectively in a scalable fashion on these environments as well. So, and by the way, maybe we should also give kudos to Lukasz. I'm not Chukaj. I'm not sure how to pronounce the name correctly, but that contributed that and helped lead that. You tell me if other credits, but really great to see.
Yeah, no, I think the work that Lukasz from Splunk and also Tiffany from Grafana Labs both have been instrumental to get these blueprints off the ground, right? And we're also having folks like there's, I guess we're like a few of us, like Tiffany, Lukasz, and Alex that are sort of like the core team, I would say, currently working on these blueprints. So yeah, really appreciate their effort very much.
Yeah. Yeah, and really...
One thing that I would like to mention as well is that, and I was thinking about that blueprint, maybe like a call to action here to end users. If you're listening to this and you're thinking, actually, I do already run OTel in bare metal, and I have a way of handling this with OPAMP or without OPAMP, and you want to contribute your reference implementation, that's something that would help us a lot, because at the moment the 3 reference implementations that we have are all Kubernetes based, right? So having one of our large end users, or not even large, you have done it in production, you're running OpenTelemetry in non-Kubernetes environments, and you want to share how you're doing it, get in touch with us. And then there is support, or you can go to the Blueprints and Reference Implementations website, and we have a section where we have like how you can help, how you can contribute. One of them is just sharing your story, let's say, and then we'll have these blueprints being backed by actual evidence.
And that goes back to the reference implementations. This is the synergy between reference implementations, that we're an organization, although a specific organization with specific trade-offs and considerations and requirements, but they put it from A to Z in production so they can really share how they done that. And then looking at the blueprint that generalizes that to the general case and keeping this cross-pollination between the reference implementations and the blueprints. So yeah, call to action. Everyone wants to take part, especially in this part that is the non-Kubernetes, is less charted. Do touch base, and again, we'll have the links on the show notes on how to get in touch, and where the pages and the SIG that handle that. And the second blueprint that's just hot off the press is about managed telemetry platforms for Kubernetes workloads. So again, now going back to those who run on Kubernetes, and still there are lots of complexities and the challenges that you need to think about in these environments. So maybe even before the blueprint, do you want to give us some examples of the challenges that you see, and what are the emerging best practices and guidance that then led to what you formalized in the blueprint?
Yeah, so I guess one of the main challenges that we're trying to solve, and I think some of these are a little bit overlapping with the ones in that sort of like non-Kubernetes environment, but in general, what we're seeing is like the inconsistent configuration at the application level, right? We talked about that previously, how you might have multiple teams that are approaching OpenTelemetry, in different parts of the organization, in a different way. So they may be in charge of configuring their own OTel SDK in their applications. And then with that, if without having a consistent way of doing that, you end up with context silos, for example. So if you don't configure your propagators to all understand the same standard for context propagation, then you'd end up with, even if you push that to the same backend, you'd end up with broken traces, right? Or disjointed traces and orphan spans. If you don't apply a consistent layer of resource attributes, for example, you may not be able to understand where the telemetry is coming from. What is, what entity is producing that telemetry? You may have multiple versions of SDKs that across the environment, So that means that, well, if you are relying on a particular, I don't know, breaking change or a semantic convention, something that is changing in a particular SDK, that makes it more difficult for a centrally managed team to deal with it. And then probably the most important ones here is like, and this is where platform engineering comes in, doing all that for each team, that creates cognitive load. That creates, that reduces the velocity of the organization in general. If you have every single team to have to do the same thing over and over again, which is configuring the SDK, maybe tuning some things, maybe configuring it to your particular backend, or your, maybe it depends on the backend that you use. You may need to use different settings, right? For, I don't know, aggregation temporality, or the way that you emit data in a particular way. So yeah, all these things just generally create bad or like lower quality in data as emitted by the applications. That's one of the challenges. And then
I
that
should
has
also
those,
mention, by the way, the skill set. Even people don't think about it. It's a lot to know about OTel. And if you need to have the skill set in each and every team, and maybe you have one champion and that champion left that team, and suddenly the team is left hanging with that, with no one understanding how it works, rather than having one specialized team, the center of knowledge, center of excellence, if you will, in one platform engineering team that spares the app teams from handling these parts and just focus on their core business logic that they need to do. So even that, maintaining, and there's a lot more in the rapid pace in which OTel project has been moving. You and I know that it's been hard for the organizations to even just deploy the latest releases, and let alone learn exactly everything that's been released. That's, I think, a major additional major load that people don't account for when they run their math on the engineering efforts. Just keeping up to date on the project and the specs and everything.
Yeah. And even if you have a set of like, sometimes, that center of excellence approach works, but then the way that you implement it can create those silos as well. So what I've seen happening with many end users is that they tend to have like, they don't always have a centralized, let's say, set of standards, right? But when they do have these engineering standards, some of them just have them as documentation, right? So you just have them somewhere and you say, well, this is the guide that you use to configure the OTel SDK. These are the settings that you use. The problem with that, as you mentioned, is that still creates cognitive load. That still reduces the velocity, because you provide the guidance and the standards and the documentation, but you don't actually provide the tooling to do it. And this is what, some of the challenges that we're trying to solve with that blueprint as well, is facilitating the adoption. So making that golden path that we all, as engineers, we're all very good, and architects as setting the golden path, but then you need to make that golden path easy to walk, right? As in, like, easy to go through. And that's what the tooling, that there's a lot of tooling around that nowadays in OTel that can help you in that journey. Maybe a few years ago, when, if you think in 2020, 2021, OTel was a different place, and then you had to do a lot of these things yourself and then build that tooling yourself. Nowadays, there is a lot out there that can help you in that. So we're trying to publicize that as well.
With things such as the injector, you can create your own bundle of the OTel Collector with the right mix of receivers and processors and exporters, and there's we mentioned OPAMP for like scaling out and centralizing the configuration. So just mention more concretely what kinds of tooling that have been built in OTel, and it's a great addition. So maybe you can tell us, so now that we understand a bit of the types of challenges, let's dive a bit deeper into the managed telemetry platforms for Kubernetes workloads. What does this blueprint entails? This is the one that you wrote yourself, so credits to you as being also the author for that. So tell us a bit more about that.
Yeah, so I think that's one of the challenges that we are trying to solve, but not the only one. There's others, like having multiple collectors and multiple clusters, perhaps, and like this config sprawl of having all these collectors in place. That's another one of the challenges in rolling out changes to that config, or pipelines that are not optimized for observability data requirements. And what I mean by this, and this is could be a contentious topic, depends who you speak to. And this is where we start to scope a blueprint, right? So this blueprint calls out specifically that the guidance in the blueprint is not aimed at organizations that may have a requirement for, 100% completion on every single span and every single log record that is produced through the pipelines, or because they've got compliance or audit requirements that they necessitate that type of reliability. This blueprint is aimed at the more common ones that we see, which are having fast production of data, as in data flow and fast through pipelines, and highly contextual data, and also lower resource utilization. So I think that's so trying to basically run a sort of lean platform, but at the same time that it allows you to govern that data, that telemetry production. And then that governance aspect as well is another one of the challenges that we're trying to solve, right? So how do you produce good quality telemetry? How do you ensure that you either you basically lower your carbon emissions or your cost storage, or your storage costs, or your telemetry costs in general? How do you ensure that teams are using the right signals for the right purpose, and so on? So again, we're trying to cover some of these aspects in the blueprint. And the main guidance in it, and I'll go into that now, is basically we'll start with the basics of how do you apply SDK config, and then we're calling here for a centralization of the config of your applications, but in an extensible way. So centralization alone can be really bad, as in if you just give people a way to deploy OpenTelemetry, but you don't allow them to extend it in an easy way, then that's as bad as not having centralization in my view, in my personal view. So if we go into that recommendation, we'll start with the OTel operator. So with the OpenTelemetry operator for Kubernetes, to apply that config out of the box, right? So if you're deploying every time that there is a pod spun up in the cluster, that emission webhook will kick in and then inject the instrumentation into that container, right? And if you can't do that, then start to basically use the pre-baked images for your containers that will have something configured under the hood to under the hood, I mean by default. So if everyone in your organization is using the same base Docker image, and it may do all the things than OTel, it may do, I don't know, things like security, networking, whatever. You can hook into that base Docker image and then provide your tooling that way, or even some libraries, right? There are certain languages that don't allow you to, let's say you need to configure OTel in a programmatic way. And if you need to configure OTel in a programmatic way, instead of telling your internal users that will be the application owners to use OTel in a certain way, or to configure the SDK in a certain way, you can just give them a library that can just call and it does it for them, right? So that's the recommendation. And there's a bigger part here, which is perhaps the guideline in general, which is to have a clear ownership of who owns the configuration and who owns the telemetry that is produced by that application. And then how we should, by following this model, you can still remain the owner of the base configuration, while the application owners have the responsibility of ensuring that the data that they produce is high quality, that they should only care about the API, and then you shouldn't really care about the SDK unless they really need to, right? That's the ultimate goal with that baked in config, is that application owners, they should add the business context to their telemetry, should ensure that it all describes their system in an effective way, but they really shouldn't have to care about configuring different parts of the SDK or batch processors or metric readers and so on. If they want to, though, they should also be able to do it, to extend it in a certain way. But by default, you basically ensure that that sort of like base layer of telemetry, that minimal viable telemetry in a way that should be produced by every service.
I definitely relate to that, because I think this is the challenge that I see out there. I think we circling back to what we said at the beginning of the conversation, is that the challenge is not just technical, it's also organizational. And the questions around the separation of responsibilities often arise, what platform teams own, what's owned by the application teams, and the limitation between all of that. So I think the fact that you took this into consideration as part of the blueprints to align the blueprints with modern platform engineering practices, I guess, to me, is a very, very crucial part of the hopeful success for blueprints, to really look at the organizational aspect, not just the technical one. And although we can't dictate to organizations how they structure, and if they even have a central platform team, or how what's the line of responsibility or whatnot, I think it is important to have a statement around the distinction between the infrastructure and telemetry pipelines versus the application, like the is more instrumentation and business telemetry, and then really try to provide the guidance around these things. So I'm really happy that there is also addressing that in the blueprint.
Yeah, there's one big as well. I was just thinking of the blueprint itself. We want it to be easy to consume, right? It shouldn't take you an hour to read it. However, we have started to put in appendices that may go into a little bit more detail into certain areas, but they don't deserve a full blueprint. And in this one, for example, there's one that I've been asked many times about this myself. It's like, should I use OTLP gRPC, or should I use OTLP HTTP for my, protobuf for my exporter? And I think the question is, and how OTel as well changed the default from gRPC to HTTP, and then so the question is, like, when should you use one or the other? And completely depends on where you send the data to, what's your architecture. So this has an appendix. This blueprint has an appendix on that is going a little bit more in detail into when to use one or the other, basically. Nice. But yeah, I think the blueprint itself takes that approach from like the application level to like deploying a centralized gateway, in which you may a centralized gateway in your cluster, but how you may also need a global gateway if you're doing tail sampling, for example, and you have services deployed across multiple clusters that call each other. And this is one of the things that, well, I also see as a common challenge as well, right? People want to do tail sampling, and then they start to think into tail sampling, but there's no single, let's say, place that says, okay, well, you need to configure we can talk about the tail sampler in the collector, and that this blueprint is not aimed to document how to use a tail sampler. That's already very well documented elsewhere. But what we're saying is, like, well, you may need to deploy a gateway at a global level. You may need to still keep your gateways at the cluster level, but then have a global gateway. You may want to, start basically from the application level, enable like always sample there and do tail sampling on the other side. Or there are other ways that you may want to think about this in a way that, you might just you might think this is all very complicated and just go for probability sampling and call it a day. That's also an option, right? But we're calling these options out in the blueprint as well, with the point of like reducing or improving the quality of the traces that we store, right? The ones that actually describe the issues that we're looking for. Sounds which good. Goes back to the challenge that we're trying to solve in terms of like cost and telemetry quality, or even carbon emissions, right? So I think all these recommendations, they all need to link back to the problem that we're trying to solve.
Yeah, for sure. And I want to have a bit of time also for the third one that is really about to come out also in a couple of weeks. So maybe by the time that you listen to this episode, it's already going to be out, which is actually the Kubernetes observability itself. So up till now, we talked about like workloads running on Kubernetes, but obviously Kubernetes itself has its own challenges for running it at scale, and we need observability into the Kubernetes itself. Do you want to talk about this blueprint?
Yeah, so that is currently, it's a little bit earlier on that one. There's a draft at the moment that's being reviewed. But I'm quite excited about that one because that will contain now what we think is going to be the let's say the recommended way to do OpenTelemetry or Kubernetes monitoring. OpenTelemetry. Yeah. So and the reason for it is that we're moving away from I guess the guidance for a long time had been, you have kube state metrics, and then you have node exporter, and then you have your Prometheus receivers, and then in the collector, and then you just query those, send that data elsewhere. Then you might need the target allocator for that. So they're like, it by itself, that would have been a quite a nice blueprint and how to approach Kubernetes observability. Now, what we're seeing is there's two things that are happening at the moment. One is the stabilization of the Kubernetes semantic conventions, which I think is huge, right? That we are actually having now stable attributes for resource attributes for Kubernetes resources. And we also have the collector components themselves that are able to monitor Kubernetes directly, right? The kubelet, or the kubestats receiver, the host receiver that's been there for a long time in terms of node metrics, and the cluster metrics themselves, and yeah, how we approach this as well is something that I'm not 100% sure now if this is going to be the recommended path, but there's definitely the leader extension. I think that's what it's called, the leader extension, that basically allows you to have, for example, for the cluster receiver, there's one of the challenges that's been forever in there in terms of KSM, for example, had the same issue with if you were to run the collector with the cluster receiver, is that you can only run it in one replica, right? So normally the architecture that would normally come out of monitoring Kubernetes used to be, you have your daemon set with with your collector, maybe doing your kubelet metrics, doing your host metrics, and then anything that you can gather at the host level. And then you had a single replica deployment maybe for the cluster level metrics, right? And anything related to any of the CRDs, like any of his custom resources, like horizontal pod autoscalers and whatnot. Or you would query KSM, which again, you might have one replica of KSM of kubestate metrics, or you might shard kubestate metrics, but in general, that's the approach. With the leader extension, what you can have now is just deploy a daemon set, and then one replica in that daemon set will be the one monitoring the cluster. If that dies, then another one picks up, which is a very neat way of basically saying, no, the only thing you need to do is deploy a collector and deploy a daemon set. And that's the way that I believe that's the way that we're approaching it. If that's not the way, that I apologize in advance, but I think that is the way.
You shouldn't be apologizing. Actually, this is an invitation for all the Kubernetes folks there that run Kubernetes, especially scale, multi-clusters, and all of that, to chime in on the discussion. We'd love to hear your feedback on that, and get more feedback, more opinion, more practices that people have already put in place to learn and to decide what are the best practices around this. So
yeah, I think a daemon set. I mean, I've worked in a Kubernetes environment for a long time, and daemon sets are always a problem, or end up being a problem at scale, because especially if you have a very if you have a heterogeneous cluster where you may have multiple different types of node sizes, and I've seen this happening where there's sometimes you may have so many daemon sets, one for this eBPF agent, one for the collector, one for Flimbit, one for this, one for the other, one for maybe another thing. You end up basically with a node that just, when the moment that the node spins up, you just have daemon sets in it, and there's no user workloads that can run on that node. So I think this is one of the things that we think can help, is centralize or consolidating that into, maybe in the future the only thing you need to do is deploy one daemon set for your observability, and that's the collector, and it does it all in that node, right? It just becomes easier to manage. But yeah, so I think to your point, I think this is something that I'm really excited to see what guidance comes from the community. Again, these blueprints are not something that we come together as like, it's not one person that does it. We basically reach out to specific SIGs, we reach out to the community. It's a common pool of knowledge that we're pulling from to say, is this the way that we think about it as a project? Is this the way that we think about as a best practice to deploy OTel as a project? So the more feedback that we have, the better. I think, in fact, the blueprint that I've been authoring, I think it's closer to I think it was 100 comments or something like that on that PR,
Nice.
which is great because it means that, conversation happens, you get more points of view, and it's great to see that level of engagement.
By the way, even in OTel Unplugged, I think the round table that we had around the blueprints, which was much earlier in the initiatives days, and still seeing how many were, first of all, excited to attend that, because there were lots of other interesting unconference sessions that taking place at the same slot, and the level of discussion that took place. And I was... before that, I knew that it's happening, but I have to say, attending that and hearing the discussion made me much more enthusiastic about this initiative and made me follow it much closer. And so it was really nice to see people passionate about that and really seeing that as an answer to this complexity problem. I do want to leave before we reach the end of the time to talk about looking forward, looking ahead. I'm curious to hear what's next for the Blueprints initiative, and also what does success look like as far as you're concerned, let's say a year, 2 years from now?
Yeah, so I think the way we see this evolving, and that's called out in one of the blog posts that we published, is connection points. Like blueprints will overlap, blueprints will link to each other. There is no single blueprint that will solve all your problems. In fact, we're calling out for extension points, and the blueprints that we're writing at the moment, as I said previously, compliance or audit logging, not covered in this one, but we already have an issue open to create a blueprint on that. Or collector deployments in highly regulated environments where you need HIPAA or FIPS compliance and blah, blah, blah. Another one that we see evolving in that way. So blueprints start to link between each other. And then the ones that, we've already got quite a few in the pipeline, which is great to see. We have that one for compliance and audit data governance and privacy, about semantic convention registries and governance of Weaver specific things. Prometheus by itself, as in how do you actually scale Prometheus with OTel, as in scale Prometheus ingesting, as in scraping.
Yeah.
And of course AI that will come in as well in terms of how do you approach MCP or different ways that we see this evolving. So yeah, I think we'll start to see blueprints being more connected to each other and being to fill the holes and the gaps that we're identifying already in the guidance. So we have a way to contribute. We're welcoming people to author blueprints by themselves, or to come to us and we work together and author in a blueprint, right? So this is the way that I see this evolving, is in a way that we have the blueprints extending, and also we make it more consumable, talking about AI, more consumable by agents themselves. So at the moment, you can go to OTel or OpenTelemetry.io, and the Kappa AI, the AI in the website will already have consumed the blueprint and be able to answer questions. But maybe something that you can integrate more into an agentic workflow. Something that we talked about recently was creation of skills and other types of formatted data for these blueprints, right? And yeah, that's pretty much it.
Sounds good. So this is a call out. I think you also mentioned about the ecosystem explorer to also again
Yes.
extend.
Yeah, so the ecosystem explorer, for those that don't know, and now it has a, at least for Java, has a builder, config builder. So you can click a few boxes and it will give you the configuration to configure the Java SDK, for example. So as I said, blueprints don't have any configuration snippets in them. We're not going to maintain config for like how do you configure Java in a blueprint, right? However, we can link to a particular, this is what we would like to do in the future, is link to tooling that can allow you to then generate config in a more automated way, right? So linking from the theoretical to the actual practical with configuration snippets that you can create.
Sounds good. So we're reaching the end of the time. So we mentioned several times that a call out for everyone to join this initiative, and we'll share the links on how to do that. We also mentioned here on the OpenTelemetry.io, but we'll share the links. And how can people reach out and follow you, Dan?
Myself, I am dangb.me on Blue Sky, and you can find me on LinkedIn on Dan Gomez Blanco.
And of course,
yeah,
on the
reach out to me.
CNCF Slack, naturally.
And of course, on the I mean, that goes without saying.
Yeah,
CNCF
exactly.
Slack, we're all there. Just hang out. Like, it's a really nice community. So yeah, reach out to us.
For sure. So Dan, thank you so much for joining me and for doing this initiative. Great to hear that, and really, really exciting to see the first 3 blueprints, 2, 3, now coming out these days. So kudos to you and to the entire team for this great success for the entire OTel community.
Thank you very much. Thanks for having me.
Yeah, and of course, thank you all our listeners for joining us on this episode. As always, this and every other episode, you can find them on your favorite podcast apps or on YouTube. And of course, you're invited to join us and follow us on Blue Sky, LinkedIn, X, at OpenObserve to stay updated about the episodes, to carry on with more deep dives. If you have questions for Dan, to me about this episode or anything else, or some suggestions, do ping us there, and we'd love to hear from you. I'm Dotan Horvitz. Thank you very much for listening. And concluding the 6th episode, 6th year of Open Observability Talks. So may the open source be with you, and see you on the 7th episode. On the 7th season, sorry.
Yeah.
Bye-bye.
Bye.